Hello, everyone. Welcome to this webinar, Pathways to Action, Exploring Climate Solutions with Inroads. My name is Ellie Johnston. I'm the Director of Engagement at Climate Interactive. With me today on this webinar is Eva De Leon, who's also on our engagement team, does communications here at Climate Interactive. Thanks for joining us. So what we're going to be doing across the next hour is talking a bit about climate change, what's going on today, and but really most of our focus is going to be on what we can do about it. We will be using the simulator En-ROADS that our team at Climate Interactive has built with MIT Sloan School of Management to look at global pathways to address climate change, create our vision for what a better climate future looks like. But first, let's get started with a poll. So we're going to be using these interactive polls to share and provide input, make this interactive, make this a dialogue back and forth. So first off, I'm just curious, everyone, could you just chime in where you are today? So Eva will drop the link into the chat, or you can visit pollev.com/climateinter935. And or if you would like, point your phone at your computer screen or your tablet screen and use that QR code there to access the polls. Looks like a lot of people joining from the United States this afternoon. This morning, we also ran the same webinar, and we had people stretching from all over the world. Europe, a lot of people in Europe, South Africa, India, Taiwan, and beyond. But this afternoon, it's mostly people in North America. Few down there. I see at least one person, perhaps down in Buenos Aires, Argentina. Oh, nice. Somebody joining us from the Great South Pole in Antarctica. That's fun. All right. Welcome, everyone. My name is Ellie, and I'm joining today from the southeastern United States in western North Carolina. So thanks for sharing that. And to get us started today, we are all coming from different places, and I'm curious, some of the biggest motivations for me when I think about why do I spend so much time working on climate change really come back to the climate impacts that are expected to occur with more warming and also that we're seeing now. So I'm curious, what impacts of climate change have concerned you the most over recent months? What do you see happening close to home, or maybe where loved ones live, or elsewhere? And very first response, floods and fires. We have this, with climate change, we live with these extremes. Go from drought conditions with fires and that sort of thing on over to big excessive rain events with lots of flooding. Hot summers, people mentioning the climate impacts in the Arctic. Warming across our world does not occur evenly, and in the Arctic in particular, we're seeing temperatures change faster than other areas. Rising sea levels in Ocean City, Maryland, wildfires, temperatures, wildfire smoke, and rainfall, forest fires, wildfires, catastrophic wildfires. One note, in En-ROADS, this tool we're going to be looking at, our technical team is working to do more research and modeling around fires. So we're hoping to release some more work on that in the months to come. Stay tuned. All right, so many really important climate impacts, and I know some of these things are quite close to home. Here in western North Carolina, where I live today, it's particularly acute. So we are facing a historic rain event. Woke up this morning to my basement flooded. We've gotten over 5 inches of rain. There's another 5 inches of rain on the way. The river down the road is out of its banks. And we are expected to be in that path for this hurricane that has developed in the Gulf of Mexico, Hurricane Helene. It's expected to bring much more rainfall to my area in Western North Carolina. I saw some people dropping pins down in Florida and Georgia. I hope you and your family is safe as this hurricane makes landfall. And you see this headline here from CBS News: Hurricane Helene on path for Florida with significant strengthening expected before landfall. That concept, that phenomenon, the significant strengthening, this is something that is happening more and more as a result of our climate changed world. So we're seeing, in many ways, my understanding is that meteorologists are seeing a similar amount of hurricanes in the Atlantic as have been experienced, but we're seeing them go very quickly from tropical storms, which is what Helene was yesterday, to where it is right now, which is a Category 2 storm. And I saw some forecasts this morning that are expecting that it could be as much as a Category 4 storm by the time it makes landfall in a few hours. So that extreme strengthening creates a really high impact, dangerous situation for coastal flooding as that storm surge becomes very high for those communities right on the shoreline, and also creates a lot of energy that drives the momentum of the storm inland. So even though communities like mine that are well inland and in the mountains can still experience a lot of impacts from it. One of the things that's supercharging this and really creating this phenomenon of rapid intensification is because the oceans are so warm right now. In the Gulf of Mexico, this graph, what it's showing you is the heat content of the ocean, of the Gulf of Mexico, excuse me, throughout the year. So by each month, the thin gray lines are from the year 2013 through 2022, what those temperatures of that heat content look like throughout the year. The blue line is that average over the last decade. And so you can see that in September, the blue line peaks when the Gulf of Mexico gets to its warmest point. This coincides with the Atlantic hurricane season. However, the thing to note that I think is so dramatic here is this dark red line representing this year. Here we are, September 2024, and this is incredible, so much higher. It says 126% of the average for the date from this researcher at the University of Miami. And so that is leading to a much higher probability that the storms that enter the Gulf of Mexico are gonna get supercharged, are gonna throw more energy at the coastal communities, be more devastating, create more economic losses, and all of the different fallout that comes from these extreme weather events quite significantly. And the important thing to note too is the oceans are acting as somewhat of they help us mitigate the high levels of heat content that the high levels of greenhouse gas concentration in the atmosphere have created. So as greenhouse gases rise around the world, this is creating this thickening kind of blanket layer that insulates our planet. And so it's trapping more and more heat. The oceans absorb an enormous amount of that heat. And we're seeing that in terms of these high temperature levels of oceans around the world. But here in particular, we're looking at the Gulf of Mexico. Fascinating stuff. And yeah, particularly acute, because that's what my reality is today in working and facing that. But around the world, just in the last couple weeks, these are some headlines that I've pulled. So 10 days ago, Shanghai was hit by the strongest typhoon it had ever experienced in decades. It made the financial district of Shanghai come to a standstill. Airports canceled flights, all kinds of slowdown there. In Europe, Europe is facing both wildfires in Portugal and also flooding in Central Europe. Countries like Hungary have experienced devastating flooding. And so again, it's that mix, fires and floods that we see again and again. South America has been in a devastating drought for months. And so currently, several South American countries are experiencing their worst droughts and fueling record wildfires. The city of Quito, Ecuador, capital of Ecuador, is facing wildfires near their capital. So that's not my purpose today, is to just lay all of these climate impacts on it. This is the world we live in right now. And what I want to spend the majority of our time on today is what can we do about it? Looking at the global level, what are the possibilities for ensuring that those impacts, these impacts that we see today, don't continue to get worse and worse? We're at about 1.3 degrees of warming today. So that's the amount of warming over pre-industrial levels. And if we continue on our course with the current policies that we have on the ground and current trends, we expect to see around 3.3 degrees of warming. But that's the future we can change. And that's what we're here to do today in the next hour, is to make a better climate future with different policies and actions. So we're going to be using the simulation model En-ROADS. This is a system dynamics simulation that our team at Climate Interactive has built with MIT Sloan. It's freely available. It's available in 20 different languages. You can access it yourself and use it alongside me as I show it to you. Some of the things to keep in mind about En-ROADS is it enables custom scenario analysis. It's flexible. You can change the inputs and the assumptions. We try and be as transparent as possible about the equations and the structure that is underlying the model. And also, keep in mind, it's globally aggregated. So it is here to complement other models that might be more, what we say is disaggregated. They might be more at regional level or different economic sector level. En-ROADS is designed to complement those tools. And but it is designed to be fast and user-friendly. You can use it yourself and to support just all kinds of discussions, to learn, strategize, and bring the best available data and science to whatever conversation you're having about potential climate solutions. The ways we use this tool are countless. We've run tons of events just like what we're doing today. There have been over 11,000 events with over 375,000 participants. And some of them are led by our team at Climate Interactive, but we're a small team. We're only about a dozen people. We're trying to do as much as we can, but we also have a community of facilitators, many of which have gone through an extensive training that we offer and are out there in the world available to run events or running events in all the different places that they work. If you are working with, say, different kinds of decision makers, businesses, policymakers, and want to bring this kind of event to an audience that you work with, feel free to reach out to us. We run all different kinds of events. 3 of Ava and I's colleagues are at New York City Climate Week right now, where they have been running all kinds of events for different stakeholder groups. This morning, our colleagues met with a number of journalists. Yesterday, they were meeting with investors and different stakeholders in the investment community. And then tomorrow, they're going to be reaching MBA students as just a few of the different audiences that they've been talking to and engaging around these topics. But back to our question at hand. How do we make the biggest impact on climate change to avoid those future climate impacts? Let's imagine a better future. So we're going to go back to the polling software, and I will open it up. And I want you to think about, what are the actions that you would like to prioritize to make the biggest impacts on climate change. So you can vote on, we have a whole range of different options here, and they correlate to the different actions that we can take on the simulator. And what I'll do is once you all vote, thanks everyone for chiming in with different votes, then we will take a look within En-ROADS and simulate the possibilities, see what works among all of these different options. All right, so in terms of popularity, it's interesting to see every time I run a workshop like this, it's always a little bit different. Today, it looks like people who are enthusiastic about a carbon price have showed up. Hello, carbon pricing advocates. 22% of you are saying set a carbon price, focusing on that. 17% say encourage renewable energy. Now, remember, you can pick 1 to 3 options. So you can spread your votes out, or I think you might be able to put them all on one. Down here, 9% saying reduce deforestation and forest degradation. 6% suggesting we look to methane, nitrous oxide, the fluorinated gases. All right. Everybody got their votes in that wants to vote? Remember, you can take a picture of the QR code with your phone, and that'll pull up the voting page if that's helpful, or just visit the link and you'll find the voting there. But let me jot down the responses here. So it looks like 21% say set a carbon price. All right, we'll take a look at that. And then a lot of people saying renewable energy. And then what do we have here? It's 21%, 16%. And then after that, deforestation. All right, well, that's actually the same list that I had from this morning too, just with different percentages. So great place to start, and we'll go from here. So let's take a look at the En-ROADS Climate Solution Simulator. This is the tool we're going to be using today. Let me make it larger for you. So what we're looking at here on the left, this is our global sources of primary energy from the year 2000 all the way out to 2100. Most of the graphs in En-ROADS, just to keep in mind, go for the whole century from 2000 to 2100. This graph showing global sources of primary energy includes coal here at the bottom. Then we have oil in red, then natural gas in blue, renewables in green, bioenergy in pink, and then the thin blue line at the top is the nuclear. On the right, we have greenhouse gas net emissions. And the contributors to greenhouse gas net emissions include the fossil fuels, and so coming from this energy mix here, and also from our land use sector and other greenhouse gases. I saw some of you mention methane, nitrous oxide, that kind of thing. Those are all contributors to greenhouse gas emissions, leading to it steadily rising, but somewhat slowing in terms of its growth throughout the end of the century. This increase in greenhouse gas emissions is leading to a steady rise of global temperature levels. We can change the graph here, look at global temperature. So here is the amount of temperature change. In 2024, I said it's about 1.3 degrees of warming that we're already seeing. So we see this level of impacts already. And with following our baseline scenario, which is a approximation of looking at the policy investment conditions that currently exist, and projecting that outwards, we would get to 3.3 degrees by the end of the century. This would be devastating in terms of a whole array of different climate impacts, not to mention supercharging our oceans with all kinds of heat, leading to species lost there, but also across land, devastating crop yields, and a number of different things. So we're going to take action, make a better world. Let me go back to our greenhouse gas net emissions graph. And so many of you wanted to start with carbon price. So let's start with carbon price. And just for context, for those of you who might not be familiar with this idea, a carbon price is a policy that would be applied to the sources of, generally it's the sources of carbon dioxide emissions in our energy sector. So think about your coal-fired power plants, your natural gas energy generation facilities, that kind of thing. Things that when you burn whatever the fuel is and release it into the atmosphere emits carbon dioxide. So a carbon price would be issued by government and would say, hey, you're not allowed to do this for free. When those carbon dioxide go into the atmosphere, it causes harm to our communities, to our society, to nature. And if you're gonna put it into the atmosphere, you got to pay for it. And so then it would be applied to those sources of emissions, and then there's revenue generated from that. So in terms of a carbon price, since there are so many fans of carbon pricing here on the webinar, write into the chat, what kind of level of carbon pricing are you interested in exploring? And I'll say before you write in, currently, by our estimates, the global average, so if you were to average all the places with carbon price and all the places who don't have a carbon price, it would be about $5 per ton of CO2 currently. At current levels. So some areas have a much higher carbon price, and many areas still don't have any carbon price at all. But if we were to have a carbon price globally, what would be the level? Okay, so thanks for writing in. I see some responses. $75, 50, 15. Let's start 100 to 150. All right, many votes for 100, somebody proposing upwards of 200, someone even going up to 400. All right, you can test all of these possibilities with En-ROADS. Let's start with $50 and go from there. So think to yourself, we have a $5 per ton carbon price right now. If we had a $50 per ton carbon price, this would be higher than many carbon prices that exist around the world, but not at the highest levels. I want to say, I think it's Sweden, and I want to say Uruguay. Somebody could correct me in the chat if I'm wrong. I think those two countries have some of the highest carbon prices, and I want to say they're around like $150+ per ton. So if the very highest levels are like 150 in these small countries where they've directly applied it to their few fossil fuel emissions sources, that's one level. But we're talking about the whole world here. So let's say start with 50. Before I enter $50 per ton, think to yourself, what kind of impact do you think that's going to make in terms of this global temperature number? So it's at 3.3 degrees. And here, I'll show you this graph might even be more helpful to think about it. So this graph that we're looking at here, it's the same greenhouse gas net emissions, but instead it's showing all the different sources of gases. So land use, carbon dioxide, fossil fuel carbon dioxide, we're gonna really hit that with our carbon price. F gases, these are fluorinated gases, methane, CH4, N2O, nitrous oxide. So with the carbon price, we're really going after those fossil fuel CO2 emissions. What do you think the global temperature level will be with a $50 per ton? Just, you can think to yourself, or you can write it into the chat if you like. And let's enter it in, see. All right, so let me replay the change so you can see what just happened. So we were at 3.3 degrees, now we're down to 2.9. And you see here, first, I'll work backwards. So we're at 2.9 degrees. Then over here, greenhouse gas emissions. The dark gray area representing fossil fuel CO2 emissions. It was going up. It was kind of flat, but it was kind of going up. And now it's coming down. Not really fast, but coming down some. It definitely is peaking here right now. And over here on our left graph, again, I'll replay the change. This is what it was. This is what it's now doing. Really, my eye is drawn to the bottom here, looking at coal. So when we implement a carbon price, coal in particular gets hit pretty hard. And that's because coal is one of the most carbon intensive sources of energy. When we burn coal, it releases a lot of carbon dioxide into the atmosphere. And so if you want to have a coal-fired power plant and produce energy from coal, where there is a carbon pricing policy in place, it's going to be expensive. For every ton of CO2 you release, you're going to have to pay $50, and that can add up quick with coal. So we see coal goes in decline. It doesn't get entirely eliminated, but definitely it's more expensive to operate a coal-fired power plant than it would have been otherwise. Other things, natural gas comes down some, and oil comes down some too. So that's $50, but some of you all had proposed to do even more of a higher carbon price. So just because this is a tool, I moved the level, that enables experimentation, we can adjust this. And we could say, okay, well, what about $100 per ton? We saw that we went from 3.3 down to 2.9. What if we double the carbon price? How much further does that get us? That gets us another 0.2 of a degree. Coal is squashed out even more. It's even more unaffordable to generate energy with coal. Natural gas also getting squeezed there as a result. So yeah, it's coming down. Carbon price is a powerful lever for addressing our challenge of greenhouse gas emissions. So that's great. We're going direct to the heart of the challenge and addressing it. But we got to think about some of the other impacts. If you just implement a carbon price globally, what are some of the considerations that we need to take into consideration? And I bet you all have some ideas and have thought about this. So let's go back to the poll. And when we implement a carbon price, what are some of the ways that implementing a carbon price could harm communities? And then in a second, I'll ask you all, how might we be able to design the policy in such a way that it could help communities? Just as a brainstorm, so we acknowledge some of the sensitivities and nuances with implementing this. In what ways could implementing a carbon price hurt communities? We know it benefits greenhouse gas emissions. There could be job losses. Fuel could become more expensive. Yeah. We have to pay attention to environmental justice and equity. Yeah, what are some of those environmental justice and equity concerns? It affects poor people most, so you need to accompany it with social measures. Yeah, and the reason why it impacts poor people most is because if you put a high percentage of your income to paying for gas to fuel your car or paying for electricity, it means that you might have to compromise on paying for something else. And so when your budget is very constrained, that becomes more and more challenging. So yeah, the increases in prices of electricity, all of those kinds of things. These are really important considerations that we must take into consideration when thinking about the potential possibility with the carbon price. Now, I'll go to the next slide. Have some of you all thought about, or do you all have ideas as you think about it? In what ways could implementing a carbon price, on the other hand, benefit communities? Air quality, absolutely. We'll take a look at that in a second. What are some of the other ways in which a carbon price might be? What are some of the ways it can be designed to be more helpful for communities to help avoid some of those impacts around energy costs? Income generation. Yeah, that's getting at it, right to the heart of it. When you implement a carbon price, it also generates revenue. So there's something there about where that revenue goes. If it's just going to the government's pockets and enabling them to have nicer couches in their office or whatever it might be, not helpful for communities. But if that revenue is put strategically towards different kinds of aims, then it could be help to mitigate some of those equity considerations that you all listed before. Things like more mass transit. That's a great point. You know, if costs for transport go up, how can we provide more means for people to get around? Revenue redistributed to adaptation solutions. So there's all different kinds of ways the revenue could be used. Someone else suggesting revenue to train oil and gas workers to help that job transition. Maybe the revenue, here's someone else, more climate adaptations, or just redistribute the revenue to all the people who are facing the higher costs. There's an example of this in British Columbia in Canada, where the revenue is just redistributed out to people. So there's a bunch of different considerations here that to consider as we think about a carbon price. And so if we go back and we look at En-ROADS, and one of the things you can look at is like, okay, what's going on with the cost of energy? You see this spike as a result of the carbon price we implemented. So again, think about where that revenue can go in a strategic way, such that we can avoid the equity considerations and the injustices that can result when energy costs go up. And we don't have ways of modeling that all out in En-ROADS, but it's an important factor in the discussion that we must bring up. But yeah, there's lots of possibilities out there. So that's carbon price. It's $100. Some of you all propose to make it even higher. We could keep pushing it up. Or you can visit En-ROADS yourself and do it later. The carbon price can be pushed quite high, well above what any country has on their books today. But I want to keep moving on to some of the other suggestions you all had. And the next thing that had the highest amount of votes for adding to our scenario for a better climate future was encouraging renewable energy. So renewable energy is reflected here in this graph, showing the green area. And I will show you all renewable energy, primary energy demand. So check out this graph too. So this shows I haven't done anything to specifically boost renewable energy, but you'll notice that already our renewable energy is getting a boost from the baseline level as a result of that carbon price. When we make the fossil fuels more expensive, it means that renewables comparatively become more and more attractive. So we see more renewables getting used just as a result of that carbon price. But let's boost it even further and say, what if renewables was even cheaper than it is today? And another graphic we can look at to see that is by looking at the financial level. So the marginal cost of electricity production by source. Let's view this. So each of these lines reflects different energy sources, and you see coal going up, becoming much more expensive as a result of the carbon price. Same with oil, getting much more expensive. Gas too, getting higher. And wind and solar in particular, falling from the year 2000, falling, and coming down. Think to yourself, I'm going to highly encourage renewable energy. We're going to put a big subsidy on renewable energy. How much is that going to drive down temperature change? And think to yourself what you think it might be. And I'm going to move the slider. So here we have it. Subsidized, highly subsidized. I'll just max it out for the effect. So we went from 2.7 and we're still at 2.7. So we don't see a temperature change here. We do, however, see that renewable energy is going up. So it is getting a boost as a result of cheap renewables. Costs are coming down, so they're basically rock bottom. But then you see they kick up. That's kind of interesting. We can look at what's going on there. The other thing I'm interested in looking at is, so we didn't see any kind of temperature change here. What is going on there? And one thing I want to look at is energy consumption. So here's where it was before. It's a subtle change. View this larger, but maybe you all can detect this. So this is without our renewable energy subsidy. our energy consumption is like 570, and this is with our renewable energy subsidy, and that energy consumption goes up. So this is a dynamic where cheap energy increases energy consumption. So there's some, and this is what we call a balancing feedback loop. So there's some balancing effect. You have cheap renewable energy that boosts energy consumption. And so people consume more of it. And as a result, there's not as much of a benefit in terms of reducing things. The other thing that let's look at this dynamic here of what's going on with the cost. So it's going down, 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 but it's then rebounding and popping up. So I'm going to zero in on this by looking at the marginal cost of wind and solar. So this graph here, so here's our cost, wind and solar, falling, falling, falling steadily, 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 steadily. But then we have this new cost that comes in to be factored in, storage costs. The wind doesn't always blow and the sun doesn't always shine. We hear this all the time from people pessimistic about the future of wind and solar. But the fortunate thing is there is a flourishing technological startup, technological development space, particularly here in the United States, but also around the world in terms of energy storage. All kinds of different technologies being piloted that help to address this question of the intermittency of wind and solar. And so that's where this cost comes from. As wind and solar becomes a higher and higher percentage of our electricity system, let me looking for my electricity graph, electric final energy consumption by source. So you see this is, so first off, one of the things to note, especially as you're hearing you read a lot about energy and these different topics about the different types of energy sources we have, pay attention to this. We were looking at a graph of energy supply. So that's including our uses of electricity, but also fuels. When you fill up a car with gasoline, that's a fuel, that's not electric. If you have an electric car, then of course you're plugging it in, then you're pulling from the electrical grid. So in this scenario, although we still saw that there was a lot of coal, oil, and gas being used, a lot of that was in the fuels sector. This scenario, by and large, our electrical grids globally are highly dependent on renewable energy. We are seeing this shift already where renewables can dominate more and more of the electrical grid, and we have to do all kinds of electrification. We have to pivot our technologies, switch from fuel-based cars with internal combustion engines over to electric vehicles through electrification of our transport systems and also buildings and industry. But this high percentage of renewable energy that happens, that transition that happens right here in this 2030 zone where we had some other energy sources has to be met by increased need for storage. And so that's where that cost from storage comes into play. Let's see. I see a question about the marginal cost of coal. Let's look back at that. So see the marginal cost of coal coming up. Why is it coming down somewhat? I think that is a good question. What I'm assuming, and actually, I think Rosella, who's asking this question in the chat, this is a great thing, and I actually want to look into it because our team is working on some market dynamics of our modeling that might change the outcome of that, but I'm not quite sure. But basically demand falls for coal because renewables becomes the dominant thing, and so I think prices fall as a result of that. And we have less coal being used. There's just less appetite for coal. But that's a great question, Rosella, and one I could come back to. All right, so we're at 2.7 degrees with our carbon price of $100 and our big subsidy on renewable energy. One thing I want to mention that somebody brought up when we were talking about some of the benefits of a carbon price is with these two actions, what does it look like in terms of air pollution? So one of the benefits of moving so dramatically away from coal is that we see the benefits to air quality. So here, this graph, if we look at it larger, this is air pollution from energy sources. The biggest contributor to that is coal, but also oil and gas. And this is measured in PM 2.5 emissions. PM 2.5 emissions, this is the size of the particulate matter, and this particular particulate matter of 2.5 microns is very irritating to our lungs. It aggravates them, it causes asthma and other respiratory health conditions that are particularly acute for those communities, those people who live in close proximity to coal-fired power plants. This is a huge environmental justice challenge. So many coal-fired power plants have historically been sited in poorer communities in the United States. That's communities of color. And as we work to shut down and transition away from coal, it results in healthier air. This is a win-win and a big benefit to those who live in close proximity to it. But of course, as also was acknowledged in some of your feedback, we also have to factor in those job losses that come alongside that. So multiple things to think about as we see this shift away from coal and other fossil fuel sources in the scenario we've created so far. The third thing you all were mentioning and suggesting that we take action around was deforestation and forest degradation. So far, we have taken action in the energy supply category. So we've been really focused on this energy question. That's really important because, as we see in this graph, here in 2024, the biggest contributor to greenhouse gas emissions is from fossil fuel, carbon dioxide. But down here, you see this is reflecting our land use carbon dioxide emission, the green area here. That's largely driven by deforestation. So deforestation is the logging, the harvesting, burning in some cases of land and switching it from forests to crops. That's the biggest driver of deforestation. Our global need for more and more land to raise cattle, put other animals out to pasture, and to grow crops from soy to corn to wheat, all kinds of things. And let's check out this graph of the emissions from deforestation. Actually, this isn't emissions. This is the land area. So million hectares per year from deforestation and mature forest degradation. Mature forest degradation, the idea here is that a mature forest, also known as like an old growth forest, it's a forest that's over 100 years old, degrading those forests through harvesting. So just logging it and then letting it regrow releases a lot of emissions to the atmosphere too, because old forests that have had lots of time to mature have both big old trees in them and also a lot of carbon stored in that soil. So while we can continue to harvest wood products from medium-aged forests or younger forests, it's important to consider how we might preserve and protect the oldest forests of our world, and also huge reservoirs of biodiversity. So important there. When we move this slider representing deforestation, we're also reducing the logging in those old growth forests. So we're addressing both. Before I move this slider, so you saw it's very sensitive. Our renewables slider didn't change much. Sometimes there's a rounding, you can hover over and you can see, okay, we're at 2.65. So it's right on the threshold of rounding up to 2.7. And we can reduce this deforestation down. How far do you think it's going to bring down temperature? I'll just say, what if we highly reduce it? What if we are successful? There are these global targets to reduce deforestation. I think as soon as 2030, in some cases, there are these really ambitious goals that we need to stop net deforestation and use the land that we already have for farming and agriculture and all of our other needs rather than continuing to expand it. So we were at 2.6 degrees. That comes down to actually we were at 2.7 degrees when I started this slider. But we get about 0.1, 0.2 degrees. That is reflected here, view larger, in our land use CO2 emissions. You see that was up here, and now it's getting to be very narrow, so it's nearly gone by the end of the century. It helps. It's not the magic fix that's gonna make all of our climate concerns go away, but it's an important piece of the puzzle. Sometimes we say it takes many seeds to plant a garden. And here we have 3 seeds in the ground, 3 big seeds. You all keyed in on some of the high leverage areas. Back to you all though, I want to see your votes. And I'm curious, you've seen the actions so far. If you could make an additional change to our scenario, which area would you vote on? Just you when you pull this poll up, you click on it tap on it with your finger if you're using your phone, or click on it with your cursor. Which area should we take action on? We could address electrification in our transport sector, more electric vehicles, electric buses, nature-based carbon removal. I see many people looking over there. That's things like planting a lot of trees to draw down carbon. Buildings and industry energy efficiency. We've got the most votes over there for people voting on that. All right, more votes coming in faster here. So more people suggesting we look to energy efficiency in buildings and industry. All right, I'll take that as a win. I know. I'll give you all just a minute to get a few more votes in. Building energy efficiency across the board, both buildings and also transport. All right, let's go there and check out how will that help our scenario, and see if we can get the global target is to limit climate change well below 2 degrees and aim to keep it below 1.5. So we're at 2.5. We're making steady progress, but we have further to go. So buildings and industry, energy efficiency. What this is doing, as I move this slider, it's enabling us, we're doing the same amount of commerce, same amount of work in the world, but we're just doing it with less energy. This looks like all kinds of things, from updating appliances, so maybe switching light bulbs and other kinds of cooking stoves, all sorts of things in our homes, offices, and industrial facilities. In the industrial sector, there's all kinds of things that could be done to harvest waste heat, for example, and reuse it such that it's not it doesn't require all this extra energy to burn. All kinds of different possibilities here. So when we scale this up, what we're doing is increasing that energy efficiency level. And I'll just move it all the way again, just to see what that impact is. So we were at 2.5 degrees, brings temperature down another 2.3 degrees. And notice where this change is biggest. Over here on global sources of primary energy, what's going on is, this is where we were, this is where we are now. Total global primary energy demand goes down. The economy is still growing. We're still meeting the needs of the world in terms of energy, but we just require less of it. We can really see this if we go back to our energy consumption graph. So here's where we were with energy consumption, steadily rising. This is in a world where population is climbing and economic growth is climbing. So energy consumption has to grow to meet it. But with our energy efficiency actions here, we see energy consumption coming down. That was a great suggestion from those of you all who had proposed it. And while we're at it, several of you all were proposing we also do energy efficiency in the transport sector. So we can do that as well. And we'll see the same additional benefits. So this is things like hybrid vehicles, or using mass transit to get from one place to the other. If more people crowd into a bus, as opposed to all driving single family cars, then that's a way to get from point A to point B. You get the same activity done, but it's done with less energy. That brings us down to 2.2 degrees. We are nearing the top of the hour, so we're getting close, but we're not there yet. One of the things that we can move to next that I saw many people voting for was around nature-based solutions. So all of the actions, energy efficiency, this is about our consumer habits and the habits of our businesses and industries and how they consume energy. We spend a lot of time thinking about where the energy comes from and how to make better choices there. We touched deforestation in our land use sector. The one area we haven't touched is carbon dioxide removal. So this is the idea. One of the ways to think about the climate system is like a bathtub. Everybody knows how a bathtub works. You have your faucet, your tap, in which the water comes into the bathtub, and you have the drain in which the water goes out. So if the level of the concentration of greenhouse gas emission in the atmosphere is like the level of a bathtub, we have all the emissions coming in, which is largely what we have tried to address so far. If your bathtub is overflowing, the first thing you should do, turn off the tap. So hooray, we've been doing that. But once you've turned the tap off, you might want to also be looking at other things. And so this is where this question of, okay, can we do anything to the drain? Can we do anything to this climate bathtub's drain and increase the removals such that the level of greenhouse gases in the atmosphere comes down? This is where there is a lot of discussion about nature-based solutions and also other technological approaches. When we move this slider, we're boosting afforestation, which is planting trees on a large scale, and also scaling up biochar, which is a way of taking biomass and storing it in the ground permanently so the carbon of that biomass isn't released into the atmosphere. And we can scale this up and we could say, okay, what if we have medium growth level of nature-based solutions? We could even push it up and say high growth. That gets us to 2 degrees. And so that brings down greenhouse gas net emissions. Here's where we were. And it's bringing down greenhouse gas net emissions because we're increasing the removals. This is a graph that's subtracting out the removals from the emissions. We can see this more clearly here on this graphic showing our stacked. So before we were just mostly, everything was above the 0 line here going across. And now you see this addition of the land use CO2. So that's our afforestation. And then the gray is from biochar. So they're now drawing carbon down out of the atmosphere, helping to balance out the global levels. That gets us to 2 degrees. Well, I'm afraid we're at the top of the hour. We're getting very close. So I want to stop here. And your challenge, I'm going to leave you all with some homework, is that we need to do better than 2 degrees. Can we do better than 2 degrees? Here's our scenario. I'm putting it into the chat. You can open it up on your laptop, your computer, your tablet. Unfortunately, En-ROADS doesn't work on a phone. The phone screen is just too small. We haven't been able to design that yet, but open up this scenario and push it further. And if you don't like some of these decisions here, maybe you thought the carbon price was too high, feel free to change it and make your own scenario. And then when you do, you can share it. Share it on X, formerly known as Twitter. Share it on Facebook. Share it wherever you like. Send it to us or send it to a friend. And see what you come up with as a possibility. And as a remember too, this tool is available in many different languages, so feel free to also change the language if that's helpful for whatever audience you might share the tool with. So That's exciting. We got to 2 degrees. This is a much better world than where we started at 3.3 degrees. Of course, we need to do even better. This is going to be tough, the level of action that we deployed here today, but also signs are that things are moving. And actually, I found this graphic just last night. So I was thinking about talking to you all today. Let's see. This is just one of many different kind of hopeful stories out there about this energy transition that's underway. This is a graph from the year 2000 out to 2024. The world is on track to install a record 593 gigawatts of new solar capacity this year. Last year, looks like it was maybe even less than 500 gigawatts. The year before that, it was less than 300 gigawatts. So things are scaling up much more rapidly. As a result, the transition is underway. Thousands of people are talking about climate solutions in New York City this week, exchanging ideas. Our colleagues that are on the ground say that there's a whole lot of discussion, particularly among advocacy groups, about the need for a fossil fuel phase out and pushing for that to be adopted by businesses. Last week, at the UN Forum for the Future, they how many countries was it, Ava? I think it was like 160 plus countries signed on to this pact that said that included many different things, but it said that we should aim towards phasing out fossil fuels. So there's momentum building behind these ideas, and the challenge that we face is we're facing impacts today, as we acknowledged at the beginning, and we're working to make this transition. We've got to move faster. We've got to move at speed. We've got to move at a really large scale. And that's our challenge for the generation of all of us alive today, the generations alive today. And I have full confidence that you and me and all of us together joining from all over the world, this afternoon webinar, the morning webinar we had, can make some difference in that big, big global challenge. Thank you all so much for joining. And if you would like to take this further, please do. We have a training course that you can take and you can learn how to be a facilitator. I saw some familiar names in the chat. Some people have just wrapped up what we call our En-ROADS Climate Ambassador Camp. But we have the training available year-round that you could take at your own pace. Find a trained En-ROADS Climate Ambassador, invite them to whatever audience you reach. Think about the policymakers, the decision makers that you know or you could reach out to help advocate for and push for the suite of different actions that we showed today. Thank you all so much. And I didn't get a chance to answer too many questions. I was kind of only half looking at the chat, but I would love to stick around for a few minutes, answer any questions that came up that we didn't address. But if you have to move on to other things in your day, please do. And thanks for joining us.